Hi guys, welcome back. In this video, I'll be explaining the concept of series. In the last video, I explained the meaning of arithmetic progression and how you can find the nth term of an arithmetic progression and the application of this nth term formula to solve an arithmetic progression involving a word problem. When we say series of a sequence, so it is when the terms of a sequence are added together. So when you add the terms together, the expression you obtain is what we know as series. In essence, series is the what? Is the sum of sequence. For example, if I have 1, 3, 5, 7, this is a sequence because it follows a particular order. This is a sequence. So series will now be what? 1 plus 3 plus 5 plus 7 plus dot dot dot. So that is the addition of what? Of the terms of sequence is known as what we call series. And you can have two types, we can have two types of series. Number one is known as infinite series. When we say infinite series, so that is, it is a kind of series whereby the number of terms is unlimited. Yeah, that is, it's infinite. For example, the example I gave here, 1, 3, 5, 7. So is an example of infinite series because the number of terms here is infinite. So now you cannot find, I mean, you cannot, this is infinite series. You may not be able to get a definite answer for an infinite series because it doesn't end. You understand now? But let's say I have something of this nature. For example, if I have 2 plus 5 plus 8 plus dot 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 plus 41. You can see this is an example of series as well because it is the summation of the sequence 2, 5, 8 up to 41. But this is an example of finite series. Why is it a finite series? Because it has an end. You can see that the last term here is 41. You understand now? So when you now have a finite series, it contains a definite number of terms. So in essence, it is possible for you to find the sum of a finite series. Again, don't forget when you have an infinite series, that is when you don't have a definite number of terms. So when the number of terms is unlimited, then you cannot find the sum of such a series. So if that is cleared, so let us move to the sum of terms of an AP. We don't forget, we already know what an arithmetic progression means. So we know an arithmetic progression is also the same thing as arithmetic sequence or linear progression. So that is, it's a type of sequence in which the consecutive terms increase or decrease by what? By adding or subtracting a constant. Okay, now let's say we want to find the sum of the sum of terms of an arithmetic progression. Remember that your arithmetic progression is of this sequence. You have your A to be the first time, A plus D, A plus 2D, A plus 3D, up to what? Let's say, yeah, let's just say L minus D, that is the last term minus the common difference, then the last term. The last term is also the same thing as nth term, like you know. So if you want to find the sum of this series now, this is our AP, right? Because it followed some certain patterns. In fact, so you have your common difference here, so such a way that the relationship between two consecutive terms is either addition of that common difference or the subtraction. You understand that? So it means the sum now, which is series, let's denote it by Sn, will now be A plus D, A plus 2D, A plus 3D. Let me just put it into brackets so that we don't confuse, it doesn't confuse us. So then this is L minus D, then plus L. So then plus L. If that is the case, I can rewrite this as this again, L plus L minus D. Is that not so? I just interact it. I started from the what? From the last term. You know, don't forget from the definition of AP, I said it's a kind of series which is what? Which is obtained when the consecutive terms increase or decrease by adding or subtracting a constant term. So if we start from the last term here, then I can have something of this nature up to what? A plus 3D, A plus 2D, A plus D, then plus what? Plus A. I hope you understand. So then if that is cleared, then let's say I call this one equation 1 and I call this equation 2. So if I add these two guys together, that is your xn plus xn, then I'm going to have A plus L. Is that not so? Then plus A plus D plus L minus D plus dot 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 plus L minus D plus A plus D, that is this guy and this guy, then plus L plus A. Is that taken? So if you now simplify further, now I have xn plus n SSN, which is the sum. So Sn plus Sn will give me what? 2xn. So you can see that this will give me A plus L plus what? This guy will cancel this. I have A plus L plus dot 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 plus this guy also cancel this. I also have what left? A plus L plus A plus L. What do you observe? So you will see that I have my 2xn. So it is like you are adding A plus L. How many times? This is what? Up to nth term, which is last term. So it means it's just like doing, it's like saying n multiplied by A plus L. Remember, it is just like when you have 2 of AL, 2 of AL, can say 2 times A plus L. But now we have like n of AL since we have our last term, which is the same thing as nth term. That's why we have n into A plus L here. So then if you now make your Sn, which is the subject of the formula, then I'm going to have n divided by 2 into A plus n. And don't forget, from your sequence, from the end term of a sequence, recall that your L, which is the last term, is what? A plus n minus 1 into D. Then if you substitute back here, then I'm going to have n over 2 A plus A, this guy, plus n minus 1 D. You understand now? Then you have Sn is equal to n over 2 into 2A plus n minus 1 D. You understand now? So these two guys now, these two formula is known as what? You can use it to find the sum of an arithmetic progression. You can use it to find the sum of an arithmetic progression, where your n here is what? Your n is number of terms. Your A is the what? First term. Your L is last term. And your D is equal to common difference. And your D is equal to common difference. So if that is understood, let me give you an example to back it up so as to understand what I'm trying to say. Excuse me, sir, what's the difference between these two formulas? They are the same, but you are going to use this first one here when you are giving last term and not the common difference. You understand now? When you are not giving the common difference but the last term and A, you are going to use this formula. But here, if you are not giving the last term but you are giving the common difference and N and A, then you can use the second formula. So let us apply this formula. So for example, find the sum of the first 24 even numbers. Find the sum of the first 24 even numbers. This is not difficult to do at all. Recall, sum is what? That is, when you have the sequence of even numbers, you are going to add the first 24 numbers. In fact, you can do this manually, but it will take much of your time. So how do you do that? The first 24 even number, you know the first even number is 2, the second one is 4, 6, 8. You understand now? Up to the what? Up to the 24th one. We can stop here. So since we don't know the last term. So now from here, you know this is a sequence. What we are asked to do is to add this sequence together. In essence, that is 2 plus 4 plus 6 plus 8 plus. Well, it is not an infinite sequence because it definitely has the last term, which is the 24th even number, but we don't know it. You understand now? But from here, I can conclude that my A is 2, which is your first term. Your common difference here will be what? Don't forget the common difference obtained by subtracting the first term from the second term or second term from the third term. That's 4 minus 2 or 6 minus 4. Since it is an AP, you are going to have the same number, which is the constant. Then you have your A to be, this to be 2. So now we are asked to find the sum of 24, first of the sum 24 even number. Then you write your formula. Don't forget the formula I put up there. You don't need to memorize. That's n over 2 into 2a plus n minus 1d. Then you now substitute that. You substitute this parameter into your formula. Your n now is what? 24, right? Then you have 24 divided by 2, 2 into 2, 24 minus 1, and your d is also 2, right? Then if you simplify further, your S24 is going to give me 12. This is 4. Then plus 23 times 2. That's 46. So if that is clear, then I'm going to have 12 multiplied by 50. And 12 multiplied by 50, that's going to give me 600. So it means if you get all these number, the first 24 number like this, and you add them together, you are going to have 600. You can check that out. That's what you are going to find. So if that is clear, let me give you another example. Let me just copy it here because of the time. Example. The question said the sum of the first eight terms of an AP is what? 80. First eight term, we don't know it, is what? Is 80. That is, don't forget your formula, that is n divided by 2a plus n minus 1d. You understand now? But definitely we know that my n is what? N will be 8 because it's the first 8 term. So, but we don't know what your A is actually mean or your D, but you can definitely substitute this here. And you were given the sum to be 80. So then I'm going to have xn is equal to A divided by 2, A plus n minus 1. Sorry, your n is equal to 8, which is equal to 80, right? Then I'm going to have 4 into A plus 7D. Sorry, this is 2A. Yeah, I make a mistake because that is a sum. 2A is equal to what? Is equal to 80. But when I can divide through by, 4. This implies that your 2A plus 7D is equal to 20. You can call this equation 1. So the question now continue. Then and the sum of the what? Just do it one by one so that you don't make mistake. This is the first statement. The second statement says the sum of the next 4 terms. After the first 8 term, the first 8 term, that is, we obtain here the sum. We said the sum is 80, right? So the sum of the next 4 terms. So that is the sum of the next 4 terms, which will be the 9th term, 10th term, right? 11th term and 12th term actually gives what? So gives 88. You understand now? So it actually gives 88. So that is the sum of the next 4 terms. So the sum of the next 4 terms actually give 88. So if that is cleared, I don't think you need to stress yourself. One of the things you can actually do here is that if you don't want to stress yourself, don't stress, don't add this to it first, because what is the question says the sum of the next four terms. You know, the first eight term is what? It means the sum ends at the eighth term. Then we want to know the ninth term, 10th term, 11 and 12. Then this can actually be a plus 8d plus a plus 9d plus a plus 10d plus a plus what? 11d is equal to 88. If you collect the like type 1, 2, 3, 4, then it is like 4a plus 17d, right? 17 plus 10, that's 27d. 27 plus 11 is actually what? Plus 38d is equal to 88. 2 is common. You can divide through by 2. This will give me 2a plus 19d is equal to 44. Then you have your equation 2 here. Then you can merge this guy together, combine equation 1 and 2 together. If you combine it together, what are you going to have? And I'm going to have that my 2a plus 7d is equal to 20. Then 2a plus 19d is equal to 44. So if you subtract 1 from 2, equation 1 from 2, that means 2a minus 2a, that's 0. 19d minus 7d, that will give me 12d is equal to, what is 44 minus 20? That will give you 24. Then from here, it implies that my d is equal to 24 over 12, which is equal to 2. You understand now? Since I know that my d is equal to 2, then you can substitute it in any of the equation. You can say put d is equal to 2 in equation what? In equation 1. Then I'm going to have 2a plus 7d is equal to 20. So then 2a plus 7 into 2, since my common difference is what? Is 2. So then when you simplify further, then I'm going to have what? So 2a plus 14 is equal to 20. 2a will now be 20 minus 14. 2a is equal to 6, which implies that a is equal to 3. You understand now? If your a is equal to 3, then therefore a is equal to 3 and d is equal to 2. But this question says to find the AP, that is the arithmetic progression, the linear sequence. Since we know that a is equal to 3 and d is equal to 2, and the general form of an AP is what? A plus d, a plus 2d, a plus 3d, and so on. Then you can substitute the formula here. This is going to be 3 plus 2, 3 plus 2 times 2, 3 plus 3 times 2. You understand now? Then I'm going to have 3, 5, 4 times 2. 2 times 2 is 4 plus, that's 7. 6, this is 9. You see that now? And that's your AP. That's your AP. So if you understand, don't forget I said I derive how you can find the sum of an AP. I derive two formula. The one that is having the last term parameter, which is x, n is equal to what? N divided by 2 into a plus n, or Sn divided by n over 2 into 2a plus n minus 1d. You can actually use one of these formula to find the sum of the AP. So if you understand what I've just delivered, please don't forget to like it, subscribe it, and share with your friends so that they can benefit too. Till I meet you in the next video, thank you.